You're welcome. You're welcome to this short video on how to conduct independent sample student t-test using the Statistical Package for Social Sciences, popularly called SPSS. My name is Dayo Dukoya. Now, this video is a kind of supportive video for my online course on how to develop a standard questionnaire, which is an example of psychological instrument. So in this short video, I just want to quickly illustrate to you how to conduct independent sample test, because why is this knowledge relevant? You know, in the course of that lecture on how to develop standard questionnaire, we've come to realize that there's no way you can develop a standard questionnaire or any psychological instrument for data collection without establishing the reliability and validity of that instrument. And in the course of establishing reliability and validity, you need some vital statistics to reach a valid conclusion. And because I'm aware that most people, they're not familiar with even the use of, how to conduct some of these statistics. That's why I felt I should quickly illustrate it, because I always like my lecture to be holistic, not leaving out anything. So that way the student will have a full knowledge of how to actually conduct and establish, develop and standardize the psychological instrument or questionnaire he or she is developing without having to be looking for help or be at loss, so to speak. You have everything, take all the skills you need to do it. I really want it's so simple, but then I just discovered that most of our knowledge, the way we pass it across, most of the time that is disjointed and some vital information are left out, because what happens is that you see statistics is taught as a separate course, this one is taught as a separate course. So at times students find it difficult to integrate the knowledge. They will not realize that they need to integrate the knowledge from all those various courses together to achieve a particular objective. In this case, developing standard questionnaire requires the integration of all these various courses, which is normally taken in most universities as in a holistic manner. And that's what I'm trying to do in this singular package, having everything together, well, properly integrated to achieve that common objective of developing a standard questionnaire or psychological instrument, as it were. And I hope you get that. So with that introduction, we can now quickly move on into the SPSS. Before we go into the SPSS, it's good I also show you the hypothesis we are trying to establish, the hypothesis. And in this case, we're under the construct validity. We want to establish, in this case, the discriminant validity, discriminant or divergent validity. And the expectation in this kind of validity is that your instrument should be able to differentiate or discriminate between two distinct groups. Let me give you an instance, which I've explained in the course of the lecture, but repetition is very good. Let me just repeat it, because even this video, short as it is, should be holistic or in nature too. And so when you want to apply this kind of, to understand the kind of statistics, why we're applying these statistics at this particular instance, the hypothesis, of course, is this: to establish this validity of what we call construct validity. This example is this: I'm trying to develop a new intelligence scale. And of course, all over the world, we all know that intelligence scales should be able to discriminate between gifted and talented students who are supposed to be extraordinarily high in IQ, as against those students that are mentally challenged, we call MR. So it should be able to differentiate very clearly that there should be a significant difference in the performance of those two categories of students in such an intelligence test, if indeed it is valid, if it has construct validity. That's the hypothesis, and you all agree with me. So that's the hypothesis we are out to test now in this situation. So in such a situation, you get those groups of students that are mentally challenged, certified by clinical psychologists or by psychiatrists. It's established. Then you get a group of gifted students, and then you administer this, your new instrument, on them. And then you get the scores, and then you're going to get two sets of scores. This time around, your scores is coming from two distinct groups, as against the scores coming from the same group. For the intervention validity, which I've already posted the video, for the intervention validity, we did a pre-test and post-test on the same set of people. That was why we used dependent student t-test, or paired sample t-test. But in this case, the result is coming, you administer your instrument on two distinct groups, the gifted students and the mentally challenged students. So you are having two sets of scores from two distinct groups. So when you want to test this kind of hypothesis, you have the best ideal statistics to use is the independent student t-test. And that is what we're going to use in this situation. And the hypothesis we are trying to test is that, I mean, the alternative, of course, would be that the gifted students should perform significantly better or have higher significantly, should perform significantly better than the mentally challenged students. And I think we all agree with that. That is the hypothesis. Once you're able to confirm that actually they're able to perform better, the result coming from your instrument shows that your instrument is able to discriminate these two groups clearly, and it confirms that the gifted students are superior in terms of IQ as measured by your instrument as against the mentally challenged. Then it will be a confirmation of the construct validity of your instrument. I hope you get the logic. And so it's like I'm explaining that particular construct validity all over again, but it's good so that in case you didn't get it at my initial explanation, you will get it at this point. Repetition is a very powerful tool for learning. So with that background, we can now see the reason why the right statistics to use the independent t-test. So we can now go on to the SPSS to now conduct the analysis to reach a conclusion. Now, there's something very unique about independent student t-test. The way you arrange the score, the measurement, the value inside the SPSS is different to that of the dependent or paired sample student t-test. Let me again, for beginners, understand that in SPSS you have two views. You have the variable view and the data view. If this is your first time, I've already explained how to set up this variable view in the two initial videos. In the initial video on correlation coefficient, just go to it. You have it on the same model here. On the same platform here, and then so you just go to it, especially the issue of scale is, measure, the level of measurement is very critical. The SPSS has collapsed the two upper levels of measurement, the ratio scale and interval scale into scale. So you have three levels: scale, ordinal, and nominal. You have nominal, you have ordinal, you have interval, and ratio. The ratio and nominal have been, the SPSS has collapsed them into scale. And that is what allows for parametric statistics. And so you can see that already, that this is scale. And of course, because it's an independent student t-test, you collapse the two groups, the data for the two groups, you combine them together in the same column. That's why I've combined them. I've labeled it gifted and mentally challenged as MC. MC signifies mentally challenged. Are you following? So, and then group stands for, I now label the group for the gifted. Oh, there's something I still need to do. Under the value, I need to now differentiate or clarify the group. I actually have two groups. I have group one, which I call the gifted. So that's the way you put it, and then you had. Then group two, I call that the mentally challenged. Not just say MC because of time, you call that MC. So once you label it like this, say, okay, that will reflect. So when your result comes out, you will see that label showing. So, and that's the group. You have two groups like that. So you have two columns. So, and you label it this way. But you notice that I put nominal for the group because you just have two distinct groups. They are categorical groups. They are not continuous. That is why they fall under the nominal scale of measurement. So that's how you label it. Once you have done this under the variable view, you are good to go. You can now go to your data view and populate your data. You can see, so when I use the same sets of data. I normally use it to illustrate to my students. So you can see the same set of data here, which is post-test, is what, which is this group for the second group is what we have put there. So 111 here represent the group, the result for the gifted, and then 22 group 2 represent the result for the mentally challenged. Is that all right? So once you arrange your two variables this way, you are good to go. Please ignore all the other data. It's not relevant to what we are doing presently. It's just these two rows that we are interested in. Rows. Is it column now? These two columns that we are actually interested in. So once you set it up this way, you can now go to analyze. Then you go to compare means. Then you now go to independent sample. And then the combined result for the two groups, you put it in the analysis box here. And then the group, you put it in the group column here. And then you need to define the group. You click define group. And then for group 1, you put 1 for the, and then you put 2 for the second group. You have two groups. So then you now click continue. So once we have done this, and then under your options, I don't, all these are just default mode. It's just okay. This is talking of confidence interval of 95%, so which is okay. That is what we actually want. So all that, everything is in place and everything's okay now. So you click okay. You click okay to complete your study, and then you see the result coming out, as it were. So, and that is it. So you can now see, but you start from the mean, you check the mean. So you can see for the gifted, you have 58.30, for the mentally challenged, you have 47. Yes, agreed that the mean performance of the gifted is slightly higher than that of the mentally challenged. But the question is this, that difference, is it significant? You can know that from face value. So that is why you need to check again this second box of results. And what you are really particularly interested in here is the t-test result, not the Levin's test per se. I mean, not Levin's test. So in this case, you pay attention to the t-value, which of course, and then you pay attention to the level of significance. The level of significance is particularly very, very important. It's the same thing as the p-value, which is telling you the degree of error permitted. And the decision rule, like I've been repeatedly saying, is 0.05. That is, you don't allow for more than 5% of error. The P is the probability of error permitted. Is also the same thing as significance that we're seeing here. Is that all right? So, and in this case, you can see very clearly that it's above 0.263 is above 0.05, which means that this result is showing that the result we have obtained, the difference we have seen here is not significant. It could just be due to chance or error, so to speak, or due to chance. And so because of that, because it's above the degree of error already observed is almost going to 26%, and that is just too high to be acceptable, that to be able to take this difference as anything significant is not below our decision, the cutoff point we have already established. And that means that you accept the null hypothesis of that there's no significant difference between the performance, don't forget our hypothesis, between the performance of the gifted and the mentally challenged. That's what that means. That's what the result is showing. And so you reject the alternative hypothesis and accept the null hypothesis. And that is to further extend it, the implication of that is that this instrument, based on this data and based on this sample, the instrument is not having sufficient evidence of construct validity. That's the conclusion. That is the reason why I'm sharing with you, trying to teach you how to use this SPSS analysis of statistics to reach a conclusion on your reliability and validity. That is actually the reason for showing all this. So I need to show you how to reach that conclusion, and this is very, very important. So when you have even any question in the exam or bordering on this, don't stop until you get to this point of reaching a conclusion. Many of the students I just discovered that they don't get to this point and they lose a lot of marks. But beyond losing marks, this is actually the stage where you are able to, even many PhD students, they don't report these things in their report to show the validity of the instrument. And that is one of the most sensitive things, because we need to prove to us that the instrument used to collect data is reliable and valid. You must prove it to us. Even if you adopt somebody's work before, maybe it was done in America or Tokyo, you have to revalidate it and still show us, give us the proof, statistical proofs like this, that the instrument is reliable and valid. And that is the whole gamut I've shown you now. Nothing left out. Everything you need to know on how to develop and standardize your psychological instrument using the case study of Questionnaire is what I've given you in this course. Nothing is left out. So, but if you still need further clarification, why not? You can get across to me, because we just must get it right so that we can provoke the much needed development in this part of the continent and the world. Thank you very much for listening to me.